LAS File Analyst gave us statistics that came from the total contents of each file. If one wishes to look at some statistics specific to a subset of points, then we can use the Point Cloud Statistics Extractor Point Cloud task. Let's make sure we have our Point Cloud Task toolbar available. And we'll switch over to the Point Cloud Tasks pane. And we're going to create a new task of the type Point Cloud Statistics Extractor, and we're going to call it First Return Statistics. For point density, remember we want to look only at first returns. So under the source points, I'm going to go ahead and, as I did before, select first returns only. And I'm also going to set the scan angle requirement as I did previously, which is -20 to +20. Now on the General tab, I'm going to check the box to extract by files. And I'm going to have it extract all possible values. On the Point Attributes tab, I'm going to select elevation, min and max, intensity, min, average, max, return number, min and max, scan angle, min, average, max. I'm just following the instructions that are given in the tutorial at this point. And on the header attributes, just select all attributes and apply. Recall that this type of point cloud task produces a shapefile as output, so I need to scroll down and enter the output file name. Open the I/O manager, select the location, and I'll give it the name First Returns. And then go ahead and save that. I'm going to go ahead now and execute this task for the entire project. If you're following along on your own, you might just be aware that this will take a long time to do for 99 files. Okay, that took about 10 minutes to complete on my machine. When the process is complete, you see the shapefile. I'll make it hollow. All right, and really what's of interest here is the attribute table. So if you open this, we see that a lot of the same information that we saw in the file header is displayed, and it's all in this shapefile. It is, we said to extract by file, so we got a row in the attribute table for each of the 99 files. And if you scroll over, you'll notice we get all kinds of interesting information, the number of classes used, the maximum XYZ coordinates, how many points per class, and we also can get point density and nominal point spacing. Okay, so these are averages for the entire, or value, nominal point spacing and point density. They're calculated for the entire tile. When you have a complete tile, in other words, data that fills where the entire rectangle is filled with LiDAR data, then these are representative values. It can happen that you might have a tile layout where a single rectangular tile may not be completely filled. For example, if it's on the edge of the project area of interest. In those cases, you have to be careful how you interpret point density and nominal point spacing, because they do use the area of the entire tile, not just the area that happens to be covered with LiDAR data. So in the case where you have a partial tile, these values will be unrealistic or untrue. You can also use the same point cloud task to extract point cloud statistics for a very small area as defined by a stamp. So let's close the attribute table here. We'll go back to our point cloud task. I'm going to change the name of the output file so the results are stored in a different location, in a different shapefile. I'll call this AOI stats.shape. Also, because I want to use my stamp to go around and sample a number of different areas, I want to have each of those areas added to the shapefile as a new record. So I need to, in the output mode, change from overwrite, which would basically overwrite the shapefile every time I execute the task, to append, in which case every time I execute the task it'll just add a new record to the shapefile. Okay, and now I've made changes to the point cloud task, so I need to apply. Now I'm going to select the stamp tool in the point cloud task toolbar. And notice I've chosen a rectangular stamp. I can change the size of the stamp using the control and arrow keys on the numeric keypad. To make it larger or wider. And then when I have it the size I like, I can go ahead and just drop it to execute. You see each time that I execute it, I add a stamp. Let me make it smaller again. And so on. When I've finished sampling all the areas of interest, I can go back to the AOI stats.shape, open the attribute table, and here I see statistics that are calculated for each of the stamps that I created.